In this video, we're going to look at reading temperature values from the integrated temperature sensor on the EKRA6M4 board. As usual, we start by opening the E-Square Studio and launching a new project in our workspace. We select a C++ project. Name it My ADC. Since we're using the EKRA6M4 evaluation board, we will be selecting the board. The debugger remains at J-Link. After the project is launched, the first thing we are going to do is add the ADC stack. We can keep the ADC configuration in the default mode by using the ADC 0 channel. We are going to have to make an additional setting because we are going to use the internal temperature sensor. For this, we need to go to the input menu under the general menu, and then from channel scan mask we need to select temperature. And from additional averaging mask we also select the temperature sensor. And under add average count, it's usually disabled. You will have to make it average of 4 samples. Okay. We save. We also need to make sure that the heap size is minimum 4K. It can be found under the BSP tab. In the heap size, it has to be 0x1000, which is minimum 4K. We then generate the project contents. For this project, we are going to use the J-Link RTT application to view the ADC values. We can download this tool from the Sagar website. We can select a suitable version. And download. In this case, I am downloading a 32-bit installer. Once the program has been installed, we can go into the Sagar folder in the program files. We need to go into the J-Link folder and look for samples. The RTT sample files are present in the RTT folder. We have to copy and unzip these files. After we have copied the RTT folder and extracted the files, we need to copy the essential files into our project folder. These are the 4 files that are in interest to us. We can right click and copy them. The copied files need to be put into our project space, specifically in the source folder. So we should make a new folder under the source folder and name it RTT and paste it over there. We can then move to writing our codes. For better view, we switch to the C++ perspective. We will also make a new header file to contain all our declarations. We shall include the header files first. We will then define some constants. Once the header file is completed, we shall move into the hull entry C file. We will first include the header file just created, and then we will slowly add the necessary lines. We create a variable for storage of the value. We then create a structure to hold the state of the channel. There's a small bug that can be shown on the left pane, and the reason is it's an unused variable that has been declared. So it will go away as soon as we use this structure in rest of the code. We keep adding the necessary variables. Now we shall be adding the codes into the main hull entry function. We keep adding all the necessary functions, and the description of these functions are in these comments. We add in the further functions. Now we will create a while loop to measure the temperature continuously. Now we add the functions to be used inside the while loop. Once the calculation is done, we will be printing the data to our console. We will add a 2-second delay for each measurements. Once we have finished adding the code, we can now build the project. We select the project folder name and click on the build icon. The code has compiled with 0 errors. Now, because we are going to print out float values in our terminal, we need to follow an additional step. We right-click on the main project folder and go to Properties. From here, we find the settings under the C build, and under the option of GNU ARM Cross C linker, we click on Miscellaneous. From this menu, we need to check this box that says Use Float with Nano Printf. We click Apply and then Apply and Close. And we build our project once again. We will then connect the board with our computer through the debug USB port. And then we will select debug as Renesas GDB hardware debugging. We can track the progress of the debug in the console. Once the debug has been complete, we can then run this program from our evaluation board. We click on this resume button on top and then we run hull entry. Now that the program has been uploaded, we need to access the values using the RTT terminal. We need to find a small information before we can access the board through RTT terminal. We will switch into the C view. We need to find an address. This address is available under the debug folder. We need to look into a .map file and search for _Sega. Once we have found the line, we need to copy the address that's beside _Sega RTT. Now we open the J-Link terminal. We put in the address, make sure the USB is selected and press OK. And as you can see, the values of the temperature readings are shown on the screen.